Hey everybody, welcome to my second video on trigonometric integrals, and in this video I want to go over a U substitution example. And here is a typical example where you need to use U substitution, and this is because one of the trig functions does have an exponent and the other trig function does not have a exponent. So this is what a typical example looks like that you need to use U substitution. So let's get started right away with an example. Let's say we have the integral of the cosine of x to the fifth multiplied by the sine of x dx. So notice right away that one of the trig functions does have an exponent and the other trig function does not have an exponent. So that's our dead giveaway that we know that we can use U substitution. So our first step is we want to pick our U, and you always pick the U to be the trig function with the exponent. So our cosine of x has the exponent of 5, so we are going to pick the cosine of x to be our U. So our U is equal to the cosine of x. So now let's find our du. Our du is the derivative of the cosine of x, and the derivative of the cosine of x is the negative sine of x, and you can't forget to put your dx. And notice in our integral we have a positive sine of x dx, and our du we have a negative sine of x dx. So we want to make this du exactly the same as in our integral. So we are going to make both of them the positive sine of x dx. So if we multiply both sides of this du by -1, a -1 times du is just negative du, and if we multiply -1 times the negative sine of x, then we get a positive sine of x dx. So now notice how we have a positive sine of x dx in our du, and we have a positive sine of x dx in our integral. So now it is going to be really easy to plug everything into our integral in terms of u. So let's do that now. Let's plug everything in our integral in terms of u. So at the beginning of our integral we have the cosine of x, and we know that the cosine of x is equal to u. So instead of the cosine of x to the fifth, we're going to put u to the fifth, and instead of the sine of x dx, we know that the sine of x dx is equal to negative du, so we are going to put a negative du instead of the sine of x dx. So I'm going to put a negative du, and I put the negative in front of the integral just so it looks a little better. So now we have a fairly simple integral. We have the integral of u to the fifth. If we integrate this, we just add 1 to the exponent. So instead of u to the fifth, we have u to the sixth, and you always divide by the same. So we have u to the sixth over 6, and we can't forget about our negative sign out in the front. And we also can't forget about our constant. Always put your plus c. So now we have integrated this integral, but our answer is in terms of u. So your final answer you always want to put in terms of x. So let's substitute back in our answer in terms of x. So we know that our u is equal to the cosine of x. So instead of u to the sixth, we're going to put the cosine of x to the sixth, and this is all being divided by 6, and we can't forget about our negative sign in the front, and we can't forget about our constant plus c. So this is how you integrate a trig integral using U substitution. This is our final answer: negative cosine of x to the sixth over 6 plus c. And this is a fairly basic U substitution example. There are some other examples that are a little bit more difficult, which I will be going over in my next video. So stay tuned for that. And I hope you're really enjoying these, and I will see you in my next one.